Hello, everybody. So I have the pleasure to entertain you during your lunchtime, or in between now and your lunchtime. So welcome to the session, High Performance Traction Battery Testing. My name is Christof Salcher, and I'm an electrical engineer, electrical and IT engineer actually, working since over 20 years in the test and measurement domain in different disciplines. Over 1 year now, business development lead in DEWESoft, taking care of electrical power and e-mobility. Quick agenda, I'll shortly introduce DEWESoft as a company, then we go to the battery pack design challenge, then physical testing, at the end summary and question and answers if you have, then we can talk about later. So DEWESoft, who we are. We are a high-end test and measurement tool supplier, driving efficiency and data quality in testing. Last year we had our 25th anniversary. Privately owned, privately financed, no banks needed. We're serving 5,000 plus customers. Slovenia-based headquarters with 21 subsidiaries around the world. And continuous growth rate over the last 25 years, really impressive. ISO certified, and what do we offer? Basically sensors, electronics for data acquisition, and awarded DEWESoft X software. Where are we in the power testing field? We basically always say we follow the energy flow from photovoltaic, wind, and all power generations to medium voltage, low voltage, to the charger as basically building block into e-mobility, and in nowadays more and more battery and battery electric storage systems. And when we go into vehicle grid and into powertrain propulsions, testing hybrids and electric motors, e-axles and so forth, into mobile testing fields. So power all the way to where it's on the street, for example. So the battery pack challenge, you all have a battery in your pocket. This is what I assume, smartphone. Yeah, so it's about smartphone, tablets to power tools. We see them in drones, obviously, bicycles, in humanoid robots, all kind of vehicles on the street, on roads, on tracks. Booming at the moment is ferries. In Norway, they want to electrify all ferry traffic, for example. And then we also have a booming other element is BESS, battery electric storage systems, basically as a grid resilience factor, but also in data centers. So battery all over. Yeah. I put one of these batteries from the Q6 from Audi. I do not want to do advertising, whereas it's all good when I get some money from Audi. So here's one, the Q6. So the Q6 the module from the Q6 consists of 15 prismatic cells. There is a cell controller next to the module, and 15 modules are basically integrated, 12 modules are integrated into that pack. Oh, screen is gone. And so from top level to down, you see it's a lot of layers from junction box to the cover, fire protection plate, the 12 battery modules, interconnected with bus bar links, and also to the junction block upwards. You have the battery frame. It's basically the mechanical framing for all the modules, a cooling system, and a lower protection plate. So it's quite a complex system. It's the most expensive system in the passenger car and the most heaviest system also in the passenger car. So it's really complex. The battery pack design challenge is quite diverse. So from top level, everybody's interested in energy density. This is about less weight, size, and volume. So this is about the metric watt hours per kilo, watt hours per liter. And then we have the power density. This is about fast charging, high performance charging, megawatt charging is a pretty common one nowadays. So this is about the kilowatt per kilos and the C rate. Then we talk about temperature resilience, which is basically how to perform in hot and cold, leading to thermal management, which is really a key element in working with lithium-ion batteries. Then we have the safety. So in every respect, say a thermal runaway needs to be prevented, as this can cause some serious problems. And we have all the compliances checkbox with all the international standards going from UN for transport, ICE, and ISO, ECE, UL, basically around safety, reliability, and performance, a long checklist. Then we go to lifetime. In passenger cars, for example, you have the number of cycles for a battery pack, like, for example, 3,000 life cycles, charging cycles. You have 10 years plus of operation before it goes into, for example, second life or recycling when it's at 80% state of health. And then we have also in the best environment 15 years plus of a product life cycle. Predictability is a very key element when you look at this 15 years life cycle, for example, in the BESS. So they're all working on digital twins as aging models, for example. So this is all going to be data-driven at the end, learning from the field to basically predict failure, to predict lifetime. Circular economy is also a really big challenge because at the moment we are at around 20 to 50% recyclability of a battery pack, but this needs to go to 90–95% recyclability of battery packs. And the cost factor is the most critical actually at the moment, and this is the one where it gets political. So for the most common cells with LFP, NEC, you find in the modern passenger cars, but also in the power tools or in ferries. You're talking about $100 for kilowatt hours at the moment. It was going down -8% from 2025 on, and it's predicted by big companies towards 50% down in 2030. So batteries will be then all over. So this is really about material, supply chain, and this is where it's getting political because 80–90% of that resources is in China's hand. So product quality is basically a big checkbox here, and you need to find this balance in this matrix. So validation, verification, monitoring is really high priority. So let's look at the thermal safety. This is the most critical to me. It means you basically have a multi-physics and chemical challenge to solve. So first of all, a mechanical, then you have an electrical, a thermal, but also a chemical, electrochemical problem to solve. Because of a thermal runaway is often caused by a mechanical abuse, for example, by an impact or by a crash. Also electrical abuse by an internal short circuit of one single cell can cause basically a thermal runaway. Or by a thermal abuse, for example, by overheating, can also cause a thermal runaway. And the thermal runaway, what is it? It can explode, it can cause fire, but it can also cause some smoke out there. And this is actually one of the most critical because of the harming gases to basically health. So this is the thermal challenge you need to solve when working with lithium-ion batteries. And the latest law in the GBT in China says, for example, from July 2026 on, no more battery can be brought into circulation in China with a thermal runaway accepted. So no thermal runaway from July 2026 on. But also electrically, you need to say to battle this challenge. The electrical safety is a key element because everything over 60 volt DC needs special protection and special treatment. So preventing any sales or any health risks here is key in development, in testing, in manufacturing, in operating, and also in maintaining the battery. Basically, even to second life or recycle is a key element here, because the potential risk of a current flowing to your body, to ground, is really devastating. Can be heart attack, can be an arc with a fire at the end. So there's some physiological, thermal, and chemical effects. It's too bizarre to read all this, but electrical is basically also a key challenge. So battery pack validation is basically dealing with all the attributes, we always say: electrical, thermal, mechanical, structural, electrochemical, and functional. Yeah, so there's also a big functional. And I'm a big fan of the V-cycle, because the V-cycle is so easy to explain with left and right. Left side is the virtual world, and right side is the physical world. The left side, the virtual world, is everything about design, validation, and simulation, and this is where a lot of models are basically in place. So in electrical world, you have equivalent circle models, for example. You know this is in the top area here. Then you have thermal models where you deal about temperature and also flow with computer fluid dynamics. You have microstructural models, very comprehensive. I would say one of the leading companies in this world is in Germany located. Structural, you have finite element methods to do one thing is the durability aspect, but also the dynamics aspect. You have functional simulation and functional software in the model-based design world with MATLAB Simulink, for example, in the lead, and also some safety models. So on the left side is basically everything is on your computer, nothing is available in real. At the tip point of the V cycle, you basically create a prototype. Can be a single cell, can be a module, can be the complete pack. You create a prototype. And then every single atom, from atomic on to cell to module to pack to integration into vehicle needs to be tested, all integration levels. And this is where physical testing comes into place. And physical testing is then dealing exactly the same with electrical, means characteristics, performance, efficiency, but also thermal, dealing with flow, temperature, and so forth, leading into this thermal management, but also structural durability test in lab, and also on a shaker, and also functional tests. So functional test means, when you remember the Q6, there is a battery management system, which is nothing else but electronics with a lot of sensors equipped and networking to the overall vehicle. A functional test is also needed for the battery management system, and as this is software development, you basically better test the battery management system without the lithium-ion battery, because otherwise this would be chaos. So you also need to have a functional prototype test, and this means in a power hill, a power hardware in the loop simulator, where you do real physical testing, but only of the electronic, the battery management system. Also, EIS is a nice method, an analysis method in electrochemistry, and EIS means electroimpedance spectroscopy. Talk later about this one, to analyze basically in direction what is the state of health of this battery, and what is based on internal impedance measurement. A really interesting aspect. And safety misuse testing is basically the most exciting ones. This is the external short circuit of a big battery pack with 100 kilowatt hours. So this is also needed. So you see there's a virtual world and a physical testing world. What do we see in the market? We see more and more customers do front loading. Means all the new students and the new engineers coming from university normally think everything will be virtual. No more physical needed. Wrong, obviously, yeah? But what we see is front loading means more simulation, more modeling towards digital twin in operation. And what we see in the physical testing world is less prototypes. So not like in the old times with 100 prototypes, you only have a few prototypes, hand selected, and these few prototypes go through all domain testing. Means electrical cycling, durability, and at the end, the very end, the short circuit test. So we see less prototypes and a massive test program and a lot of multi-physics needs. All towards the target means a sign-off of this battery pack and basically start of production. But this is still the game, and the game is on because it's basically shrinking. In the old times, the passenger car was 5 years, then it was 3 years, and it was already challenging. And now we see from China 1 to 2 years for a complete new vehicle. So they're basically on the left lane here and overtake. So it means less prototypes, quicker testing, and quicker validation. So a typical battery testing program is huge. Yeah? It's starting with the cell, with cyclic aging, with calendric aging, with electrical characterization, where you basically use EIS, electrochemical impedance spectroscopy, but also with the environmental testing from the cell on. And then the cell, whether this is a cylindrical cell, a prismatic cell, or a pouch cell, then this goes into a larger set in a module type. And in the module type, you have basically pretty much the same, but on a larger scale. Means electrical characterization and validation, performance, the power cycler, where you basically use true load profiles, also look at endurance and lifetime. And then you have climate chamber testing, where you go from the 30, for example, to the plus 50 degrees C, and cycle also in the climate chamber. And then you have the structural durability and dynamics testing in the structural world, and combined testing, looking at multi-attributes at the same time, is an interesting one. I'll show you later. And at the end, the misuse, abuse, these are the drop tests and short circuit tests and so forth. So the testing program of from single cell to packs is huge, it's enormous. Yeah? I took the short circuit test first because I'm a really big fan of the short circuit test because it's so exciting. And this means that you basically have an external short circuit, and you can use it with the pyrofuses inside the junction box, testing if the pyrofuses are working, is there actually a disconnect between basically the short circuit and the battery, so it doesn't go to a thermal runaway, or you use it without the pyrofuses, without the disconnect, and this would in case then mean there can be really a serious fire at the end. For this, we've set up some nice testing and measurement stuff, and this means that our equipment here measures basically the voltage, current up to 20, 30 kiloamps in a short circuit of an energy, a battery pack. We measure temperature inside, outside. We measure temperature from the battery management system. We have high-speed cameras watching the whole process, infrared cameras looking at the surface of the temperature, and getting that complete picture into that few seconds of short circuit world, because then actually this is the last time you test this battery, without the pyrofuses, obviously. Another one is the pack cycler. This is actually pretty common, the pack cycler, and this is the one where customers basically simulate the rest of the vehicle, I can say. So you have the battery pack and you simulate the electric machine, you simulate the road, you simulate the driving behavior, you simulate perhaps as a component in a climate chamber, even temperature grade. So you're cycling basically to focus on rating, on use case simulation, on lifetime, and also on extremes, like for example, deep discharge or overcharging or thermal stress. So this is the pretty common one where we basically instrument a battery and measure also voltage, current, a lot of temperature channels, obviously inside, additionally installed, flow, and even gases. So there is a lot to measure in cycling testing. I'm pretty sure that this is the only multi-attribute battery pack testing stand in the world this size, located in the UK, where we play. And this is the one where you have all domains in the single test. And all domains means then mechanical, electrical, thermal in one setup. And this mast is basically a multi-axial table, and this multi-axial table is 10 degrees of freedom, moving the battery around, simulating driving behavior on top. So it's basically looking at structural durability and structural dynamics of the battery pack, simulating it as it would be in the true car. On top of it is a huge climate chamber where you simulate environmental conditions with temperature, humidity, and so forth. And underneath also is an electric cycler that you basically simulate, okay, now do a quarter-mile race, break down, recuperate, and then feeding it back to battery. So you simulate the electrical world in addition. With this setup, you can basically do road load data acquisition in the electrical world. And this means you basically go from the field, measuring in the vehicle all the strains and stresses and vibration and forces and everything, to simulate and replay this in your multi-attribute battery pack test stand, and then replay this basically showing complete life. So you can really look into how does the vehicle behave, how does the battery behave, and test it towards electrical and mechanical and thermal towards lifetime and end of lifetime. So what do we measure in total? There's a lot of measurement involved. One thing is obviously voltage measurement, current measurement, cell measurement, cell voltage measurement, module voltage measurement, but also a lot in thermal, means thermocouples, RTDs, infrared cameras, so there's a lot in temperature measurement. Structural durability, this is all about strain gauges, acceleration, and types. Aging is a topic, for example, for prismatic cells. You have this, for pouch cells, you have this expansion, so we need force measurement, displacement measurement here for expansion testing. And the battery management system is a big issue because it's the central and the hard core of a battery. So it means reading out basically signals from inside the battery management system via automotive Ethernet or CAN bus or CAN FD or whatever vehicle bus you take, or reading single elements out via XCP from the battery management system is also needed. And there is a lot of other sensors in addition, like humidity and gases and so forth. So Core is here getting all sensors and signals into one place, visualizing this and basically measuring in the respective tests. And this is where we have some new products here. So to basically pull that ball back. So the U-IOLITE High series here basically is a safe multi-physics measurement chain, basically from sensor, which is qualified according to ISO 61010, towards double insulated cable to have this extra protection, towards a non-contact safe connector, to a highly isolated Cat2 rated input, so that nothing basically happens to all operators and to the battery itself as well. Because you basically, when instrumenting a battery pack, you're also influencing the setup in a thermal way, in an electrical way. And so you need high mega ohm inputs from the impedance, from the measurement inputs to basically comply here. So this is truly a complete measurement chain, and there's 3 suppliers here in this world. One is SAB, for example. They deliver the complete thermocouple range to LEMO plugging. The other one is PCB. They have basically a Cat2 rated, 1000 volt rated acceleration transducer. And there's another company from Darmstadt who brings a high voltage strain gauge rosette, which is also 1000 volt rated. So this means at the end that the complete measurement chain from sensor to cabling to connector and to isolated inputs is safe. Details, the thermocouple board comes along with 4 thermocouples. All inputs are 1000 volt Cat2 rated, basically in one cable, so to minimize the impact to the battery pack. The universal module I'm really proud of is really truly a universal module, but combined with high isolation, cut rated. This can measure basically cell voltage, module voltage, even pack voltages for some packs. Can measure all types of temperature temperature sensors like PT100, PT1000 and so forth, full half and quarter bridges, IEPE acceleration transducers, potentiometers, and also standardized current, but all on high potential. So basically our customers ask, okay, what happens if the thermocouple or the strain gauge wire or anything else touches 800 volt rail voltage from a battery pack from a passenger car? Actually, nothing happens. Okay, there will be 800 volt on the connector and also on the wire, but the input is safe, and the person working with this is safe because you can disconnect the connector. It's a LEMO radial connector and it's plastic and there is no touch, so it's really touch-proof. This is the new series here. Also to mention DEWESoft X software, there's also a lot of stuff we pushed for new, and this is basically temperature. One is temperature, is infrared camera support. This is really a nice feature when you look at the big surface in a test, in a climate chamber, for example, or in a cycler test. You can put an infrared camera on top and you basically look at certain spots in that infrared camera picture and correlate with through tactile sensors you have installed in, for example, the battery pack. That's possible. Or you look at the thermal management analysis in the entropy and enthalpy, and look at the cooling system of this picture, and you get this all in DEWESoft X as a software and visualizing this. Another one we introduced just recently is EIS, electrochemical impedance spectroscopy. And this means we're basically feeding something like a superimposed signal as a current signal on top of the DC voltage level. And this means in certain frequencies, for example, stepping down from 10 kilohertz to 0.01 hertz. And we measure back basically voltage and current, and out of the phase shifting of voltage and current through different frequencies, you get basically a real and imaginary part, and you get a view on the impedance, visualizing this in a Nyquist and Bode diagram, and you can really read out, for example, the impedance of the battery pack and read out basically state of health of this battery pack. So EIS is something completely new in the DEWESoft X software. You find this on the web page if you're quick enough to scan, but I give you no chance, so I'm going to summary. So summary, we have basically a mission at DEWESoft. We want to address all core attributes in common. So this means electrical power and efficiency, thermal integrity, structural durability, structural dynamics, mechanical, you remember the expansion, also electrochemical, means the EIS, the electrochemical impedance spectroscopy, but also functional. So we are integrated in power hills with our power analyzer, for example, to test the battery management system, because the battery management system only works when there's truly power flying, and this means that you also need a power analyzer. For this, we have a pretty decent ecosystem, and the ecosystem starts with measuring all kinds of signals on the voltage level, but we also have our own high-performance current transducer, really comparable with LEM and DaniSense and what you find in the market. We have current clamps as well supported. We can connect shunts, and the complete multi-physics world with temperature measurement, flow measurement, and so forth. And the second level, we have the electronics level, where we come with sample rates from basically 1 sample to 15 mega sample per channel. We can go into vehicles with a completely enclosed stuff. And then we have this powerful communication layer, where we can talk Ethernet, but also EtherCAT, but also Modbus, for example, which is relevant in maritime software, maritime solutions. And then on top level, we have DEWESoft X. The DEWESoft X, the one-off, we basically can connect the complete multi-physics world to that single software. Really powerful, but still easy to use, I always say. But it's all open, means you can also stream at the same time from the DIQ or from the electronics layer we are OpenDuck, into a Python, into C++, C#, integrating anywhere. And we can also be controlled from the outside world via AK protocol in a test setup. So it's pretty decent solution in total. So what are the benefits? Clearly safe and high precision measurement. This is the new thing. With the safety, means safety not only in electrical power, where we deal since ages with up to 2000 volt, all protected, but also now multi-physics with completely safe and still high measurement quality, and basically efficiency winning. Because we think that the single ecosystem dealing with all the attributes is really a powerful tool to go into all kind of testing, even into multi-attribute. So there's no need for mix and mingle with different setups. And no software maintenance cost is always something where our customers say, hooray, no software maintenance, 15-20% yearly rate. One buy, and you basically use this forever. That's the gift, I have to say. So thank you very much. There's also a nice and decent battery testing page. You can scan the QR code if you're quick enough. I don't see smartphones, so you're not quick enough. And I'd like to end up with this one. The best way out is always through, from Robert Frost. So no challenge too high. Talk to us when it comes to battery pack testing. Thank you very much. And if you have the time, perfect, 5 minutes, you can ask any question. Questions? We also have a booth here, 445, just opposite. It's about 10 meters from here. You can touch the instruments. Also have a look at DEWESoft X at the software. I think live is always better than slides. Thank you very much. Enjoy your day.